Yeah. Hey, how are you all? How has been like the first 2 days? Almost we are at the end of the second day now. So yeah, great to see the crowd. So welcome you all, and like here's my talk. I'm going to talk on this Jest RAM meter. As mentioned in the first slide, like it's okay. I can use. So, as mentioned in the first slide only, like it's a disclaimer, like it's not a hate at all. Definitely, I'm going to talk about like the case study I'm here with. We'll go through like what all the problems I faced and what all the things, how I solved it, and like it's from a real-time experience, nothing else. So basically, I'm Santosh. I work for this company called One House, and like I work on like data side of things mostly nowadays. Apache Spark. Or Hoodie, anything on that, you can grab me for a chat, or anything on React also, it's my passion. So anything on front end, basically like front end security or whatnot. Like I think 2023 when I gave the talk, it was on front end security. So anything on that, like just grab me for a chat. I will always be happy to have it on. Here are my socials, and let's move on. Okay, so what's the case study? So it's a typical stuff, right? Like, how many of you are React devs, and like, is there anything like Angular or anybody? So can you raise if there is anybody apart from React? Oh, cool, decent crowd. Okay, so basically why I'm asking this is these people might not relate so much to the talk, but still, few things will resonate. But yeah, so this is a typical React stack, which if at all the company would have started working on any React app like 5-6 years before, like this is how the stack would look like maybe an year before. So pretty much React just for test running, like so basically we had test runners like Jest and Jasmine like 5-6 years before, and then like VTest was there at that time, but it was not that mature. So yeah, I don't even remember if VTest was there 5-6 years before, but yeah. So Jasmine and few other old dinosaur stuff was there for test running, but just was one thing that we predominantly used. And like if you see GraphQL, yeah, so again, we use it for a lot of reasons. I don't exactly know why at this particular case study, why they choose GraphQL as the backend. So they could have used anything like Open API or something, but yeah, here it was the GraphQL, and like we were using Apollo clients for it. And Redux, obviously for state management, it was a pretty good, big enterprise app, pretty much mature code base. Like it was already like 2 GB of size of code base kinda, and it's a mono repo. So all these, you can just imagine the kind of scale and the kind of complexity we were working on. So it is just Redux, and then like context, we were using it for pretty straightforward state management stuff like theming and things like that. And yeah, at the end, like for packing, bundling, we were using Webpack. Again, like SWC was not that famous at that time. So now comes the problem, right? Like, or now let's just check why people would have chosen Jest at that time. Like again, I'm taking you 5 years before, okay? We are doing a time travel now. So just check out. So it's simple in syntax, easy to learn. Most people are using it. Good community, decent docs. Like again, you will not get good docs if you get deeper into Jest. You just need to go through the code, and code is also not that. It's end of the day JavaScript. So you can also just go through, read through whatever is there, and you will understand. But if you jump into the internals of Jest, you will not get a lot of documentation, but on the high level, you will get all the documentation to consume it. So decent documentation, community support, and like as I mentioned, that was the only mature test runner at that point in time, right? So VTest is now pretty good. It is picking up with the like user usages, and like there are other competitors also, but at that time it was pretty much Jest, and that's it. Like Jasmine, few people were using it. I don't know if there is anybody that old here. Like maybe Angular. Oh, there is one. Good. So okay, like there are like Angular people, you didn't use Jasmine. I don't know, maybe if there is something else there. Cool. All right. So let's move on. Like these are the pretty straightforward reasons why we used Jest. And like, yeah, nobody won about all these things, right? Like you will not hit these problems on day 1 or even on day 365, which is like 1 year after, or even after 3 years after. You will hit it like when your like code base reaches up to that level, like 4 or 5 years later, you will get into this. And if at all your startup goes to that 5-year mark, so you will reach this place where like the code base is so humongous and like the tests are also like so high. And again, this is something we need to touch upon, right? Like we are like called as front-end engineers, but it's two-sided things. Like say, basically when you write the UI piece of the code, when you write the actual app logic, it is shipped and ran on the browsers. But if you see the UT's part of it, or like the E2E part of it, it's actually system engineering. It is actually running on some servers. You actually need to perform all the stuff which like a normal system engineering guy is doing, like performance monitoring, what is the metrics around it, how much time it takes, what are the bottlenecks, what is the RAM usage, what is the CPU usage, everything, pretty much everything you need to do. So that's like a two-sided thing when it comes to this UI engineering. Like there is a part of code which runs on the browser, which you run, and there is a piece of code which runs on the servers and your pipelines, which is actually the system engineering stuff, which is like UTs, E2Es, whatnot. Okay. So here, like, it starts small, right? Like everybody, when they like start with any React app nowadays, like we are in the best practices mode, like everybody suggests, oh, go write UTs, but we will not allow you to merge the PR until the UTs are there. Right. It starts small, but yeah, it grows. That's the point. And it grows so much at that level I'm talking about, 5-year mark, right? So there are snapshots, there are mocks and auto mocking, which adds more complexity when it comes to the GraphQL. Because in the GraphQL app, there is the backend is centralized, and you will not get a lot of handle to mock a particular API in the component. So what you do, you will mock the entire set of GraphQL APIs you have, and you will just override that particular API mocking for which you need to mock it for that particular test case. So auto mocking, and then comes the Node.js update. So we'll go deeper into each of these things. Like here, the snapshots, again, we just got rid of it. Like, God's sake, I don't know why they build this HTML snapshots. Nobody uses it. They just keep generating every time. They just make some changes, just regenerate it, push it. So we just got rid of that. That was creating unnecessary troubles in the just unit test cases. So we got rid. And like the normal snapshots, we were considerable in adding what part of the snapshot you want to check it. Just use this match object or whatever. Unless until you actually need to completely check the entire snapshot, don't do it. So yeah, so these are some things, but otherwise the other 3 problems will go into it. So whenever the platform engineer asks for any, like, why is your pipeline taking so much time? Like the backend engineers shipping like Java code, Golang code, or even on anything on the data side, their pipeline is not taking more than 15-20 minutes. And why is your pipeline taking like 1 hour, 2 hours? And then we'll just like go increase the RAM, right? So after a certain limit, they will like ask you, and if not, they will escalate it. So that's the same thing happened, and they escalate it. So we need to identify why the RAM usage is high. And the first thing is the RAM, right? So like why it is filled, because of the Babel most of the times. So if you see, the Babel has this peculiar dynamic transpiling stuff, and like it have like whatever the file you have, the ES modules you have, it just gets everything, puts into a runtime memory, like which is like a heap memory, and then everything is a string there, like after transpilation. And this all these strings, right, whichever is transpiled, and that is what is going to be used by the Jest for actually evaluating your test cases, basically because it doesn't keep it like a normal CJS module where the objects are, instances are stored. It's just like one module, it will be used for one test suite, and that's it. So that is where the RAM increases so much, and then obviously the plugins and everything are Node.js based, so it will be heavy. Solution. So now the solution is, what is it? Just with SWC. So if you see under the hood, like what this Jest with Babel does, it actually, as I mentioned, it uses eval, which is like you give a string and then it will evaluate whatever is there in the string. It should be a JavaScript code. That's it for the browser. And it's a browser API, and it's a blocking API. So these are all the problems. And like think of Babel transpiling so many files and then keeping it in your memory. So the solution SWC, it is it has a good amount of transpiling speed. Like how it does it does that code analysis at the start. There is some bit of static analysis going on. It also does something dynamic, but not everything dynamic. So, and then the RAM usage just goes down, and again, the execution, the plugin execution is in native Rust. And the disclaimer here again is, we had to rewrite some of the plugins that we were using for Babel, because it was not provided natively. So now coming to the auto mocking problem, as I mentioned, like the entire thing is mocked when it comes to GraphQL. So just think of, we had like the backend engineers for this particular thing, they called it API gateway, and then they had the entire platform which is built over for 5 years. All the APIs are accumulated in that one single GraphQL file. And think of how many APIs, how many objects it is going to mock. And the problem is, this mocking will happen for each and every test suite. So why not reuse the same mocked object, place it somewhere in the Jest config and then use it? That's something we tried. But the problem is, there the deterministic nature of the Jest unit test cases are missed. So basically what happens is, like you need to work on the, you need to think through, like, say the order of execution matters a lot when it comes to this, having it like a global auto mocking stuff. So these were the reasons why we didn't go with that. So the solution here is again like sharding this GraphQL APIs, like have it in different packages kinda. So now what happens, you will mock only the stuff which is required for that particular test suite, and we did it with some annotation fashion, like that's how it worked. And now, this is this OG Node.js problem. Here is something I accept the defeat. So when we were using Node 14, everything was good. We were all good. And when it came to Node 16, like everything started like going, the sail time got from like 1 hour to 1.5 hours. And when we tried moving from Node 16 to 18, then it came to the position where it's like in like 1.5 hours to 2 hours. So the only way here is like wait for the memory leak bugs to be fixed in Node.js, and it got fixed eventually in like Node 20. So we waited for it, and that's it. Nothing else we did. And like, yeah, before I leave, so this is some like glimpse of a memory I want to give you to the people. So when Jest was running in this kind of a scale, if you have been in that kind of a situation, you would have faced this. Chrome is dead, VS Code is frozen, just because the Jest is running, because it is occupying almost of your memory. And you've seen that node options, RAM usage or memory usage, 16 GB, 32 GB and all you would have given. Yeah. And thank you so much. Thanks for the opportunity. Here it.